Okay, I'm going to do a teardown of one of the 8mm dual lane Siemens SIPLACE feeders. This is a slightly different model than the ones I've pulled apart before. So these switches are the old style ones, which determine how many holes to move along, how many sprockets to move along. You'll see why inside. So we've got a tape. This end goes into the machine to start with. So you'd have your tape on the sprocket here. So I have the sprocket there, which is what the tape gets fed along. Tape coming down this channel here. This is a cover, which this one looks broken. It's been bent up, but this one looks to be working. So this retracts back when the pickup head comes in to grab the part, and closes back again when the head isn't there, so that as it advances, parts can't jump out. So fairly typical. Tape feeds out of here and straight down. The SIPLACE machines have a tape cutter, so they'll actually come along with a saw in there and cut across the tape once it's advanced down. I believe that's every 4 gantry movements. You've got to remember it's got 13 heads, so 4 gantry movements could be 40 plus parts getting picked off the tape. So cover tape gets peeled back here and goes into this small geared motor here. So this motor is just doing tape pickup. It's got a little gear here which the tape goes through. You actually see a little bit of yellow end tape there. It's got an interesting mechanism for stopping that. Both of these motors just go until they're told to stop. There's no encoding, there's not really anything going on there. So there's a little light gate in here. I can get the light on there. So this little lever here goes down through the light gate, and basically as the tape is running under here, when the motor's run enough that it's pulled, it overcomes this spring tension, it pulls the lever out of the gate and the motor switches off until the tape's been advanced along enough until the spring is now overcome the cover tape tension, and it goes back down, covers the gate, and on goes the motor again, and off it goes. So let's start by pulling apart one of these side plates. These are basically the same thing either side. These are actually 2 lanes side by side. You can take off the lane off the base. The electronics are in the base here. I'll show you those, but we'll go here. It's been a few months since I pulled one of these apart. I've only pulled one apart once before, so excuse me if I do things horribly wrong. Okay, so we've got just 6 screws, small Phillips screws holding this one in. So the thing I like about these feeders compared to pretty much every other feeder I've seen before, which is electronic rather than pneumatic, is that they're really, really simple inside. There's no massive gear chains, there's no pulleys, there's no anything. It's just simple. Okay, so that's all my screws for this off. It's got some Kapton over that motor, so sticks a little bit. But now we're inside. So we've got our solenoid that pulls the tape cover back and forth. Like I say, this side is broken, so it's not working. Very, very simple solenoid, small spring, bounces back and forth. This is our advance for the tape, or our tape sprocket rather. And now this motor is super simple. That is the encoder notch right there. 1 notch. So the way this works is that this gear here is a spiral. So as I advance this along, you'll see that there's a little lip there. So it's going to go as it drives along, and you'll hear a little thunk there, because in here, that shiny thing at the end of the pen is a pin, and that's fixed into, it actually comes all the way out the top of the case. And so if you want to advance this one movement, so as I turn this will move by one sprocket position and go click. Then, so that's your 2mm pitch. You just need to drive it until the gate here, the encoder gate, is visible, and then reverse the motor for 100 nanoseconds or until current peaks, depending on what you're doing as a driver. I don't know how theirs works, but basically it backs up onto that pin so that lip on the spiral pushes against that pin. It's now locked into position. Want to go another one? Rotate and back up. Done. Super simple. Couldn't be easier. So if we take off the other side, you should see the mirror of this, which will show you how the sprocket is driven. But it is such a simple system, and that's the system which could be 3D printed or very easily laser cut at home or at your local hackerspace. So I think this has got because this mechanism is so simple, we could really build good open source versions of this sort of mechanism. There's none of the gears, there's none of the levers, it's just go, stop. So simple. The only challenge will be, of course, getting a motor and gear ratio such that you can do that single rotation. Okay, so the other side. So being the other side of a lane, this is the opposite side, obviously. So there's a gear, brass gear, or actually looks like bronze gear perhaps, pushed onto the sprocket. So sprocket there, and that goes through and is mounted onto that. Then you've got your worm drive and a little bit of gearing coming out of the Maxon motor. And here you can see that pin goes up and click, back it goes. So that is just so simple. And the same thing for the tape advance. I mean, motors don't cost much. There's not really any reason why you can't just use two motors, really. So let's have a look at the electronics. I'm actually planning for our machines to completely replace the electronics on this. Also, another nice thing about these feeders is they don't have any contacts on the front of them here. It simply goes in onto the feeder pins. Well, there's a magnet, which this plate sits on a magnet, and there's a pin for locating. So it just guides on, and they have a pigtail coming out the back. I mean, that's not potentially as durable and kind of not as elegant as the ones which have all the connectors along the front and such. But you know what? It works, and it works very well. So, you know, the new versions of these machines are $1 million each. If it's good enough for $1 million machine, then it's good enough for a hobbyist, right? So let's pry this cover off now that the 4 screws are out. So this cover actually has the electronics mounted on it, assuming this is the same as the others. So yeah, so we have the electronics mounted here, and so we have our light gates here with the solenoids, a little PLC44. I believe that's the controller, bunch of FETs for the motors, a little bit of a power supply and such in there, a little switch mode power supply back here. And I mean, this is 1990s technology. It's nothing fancy. It's got a 12 megahertz crystal there, unless it's 12 kilohertz, being that it's pretty old. So yeah, pretty simple. couple of FETs under a heatsink, and then the rest of the FETs to drive the system. Not much to it at all. The big feeders, well, the wider lane feeders are exactly the same setup. So there you go, Siemens SIPLACE feeders. Simple as can be.